Download this code from codegive.com, link in the description below. Generating subsets using bit masking is a common technique in competitive programming and coding interviews. This method leverages the binary representation of numbers to represent inclusion or exclusion of elements in a subset. Understanding bit masking for subset generation. Given a set of \n elements, we can represent each subset using a binary number of \n bits. Each bit in the binary number corresponds to an element in the set, where a bit value of 1 indicates that the corresponding element is included in the subset. A bit value of 0 indicates that the corresponding element is excluded from the subset. For example, for a set \s equals \a, b, c \\. The binary representation 000 corresponds to the empty subset. The binary representation 001 corresponds to the subset C. The binary representation 010 corresponds to the subset B. The binary representation 011 corresponds to the subset B, C. The binary representation 111 corresponds to the subset A, B, C. Steps to generate subsets using bit masking. 1. Determine the size of the set. Let \n be the number of elements in the set. 2. Loop through all possible combinations. Loop from 0 to \2n, 1 inclusive. Each number in this range will represent a possible subset. 3. Extract subset using the current number. For each number, check each bit. If a bit is set, i.e., it is 1, include the corresponding element in the subset. Code example in Python. Here's a Python function that demonstrates how to generate subsets using bit masking. Explanation of the code. 1. Function definition. Generate _subsets takes a list of elements. 2. Length calculation. We calculate the length of the input list to know how many elements we have. 3. Outer loop. The outer loop iterates from 0 to \n, 1. Each iteration represents a potential subset. 4. Inner loop. The inner loop checks each bit of the current number I using bitwise operations. 1j creates a number with only the j bit set. The expression I and 1j 0 checks if the j bit of I is set. 5. Appending to subsets. If the bit is set, the corresponding element is added to the current subset. 6. Return. Finally, it returns the list of all generated subsets. Output. When you run the above code with the input A, B, C, it will generate the following subsets. Conclusion. Using bit masking to generate subsets is an efficient way to explore all combinations of a set. This technique is particularly powerful for problems that require generating all subsets, combinations, or permutations of a given set. The time complexity of this approach is \o and \2n, which is manageable for small values of \n